Hello, assume you as a developer wrote this piece of code where you applied the output stream API from Java. Your goal was to write a long number into a data output stream right here, and this data output stream has an inner binary output stream. After writing this number to the outer stream, you access the inner binary output stream by the to-binary method. However, the problem is that sometimes the outer stream does not properly write the input into the inner stream, and therefore it is a good habit to flush or close the outer stream. This is a kind of an API misuse, and our goal is to find and fix these API misuses automatically. This describe my colleagues Robert Heumüller and Jacob Krüger, as well as my supervisor Frank Ortmeier, and of course me, Sebastian Nielebock. We developed a cooperative API misuse detection approach that uses correction rules. Recent API misuse detectors consider the client code that may contain an API misuse and collect code samples, for example by code search, which represent similar API usages. And by these API usages, we can infer pattern specifications or generally rules that describe the correct behavior, how to use these APIs, for example by using a mining technique. Then we can verify the code by checking whether the code satisfies these specifications or not. However, the problem is many of those automatically inferred specifications are false positives, which causes many false alarms and therefore are not really applicable in practice. Therefore, we consider a different route where we do not consider automatically inferred specifications, but rather looking at real fixes from real developers. So whenever a developer fixes an API misuses in a commit, we use that commit and infer a correction rule. This correction rule is in the form of A to B, where A is a graph representation of the code with the misuse and B is a graph representation of the code without the misuse. So generally this rule describes how to transform the misuse into the fix. Then we use the left-hand side of that rule and search in other code repositories for similar code samples that also may contain this misuse A. And then we can check with our rule whether these code samples contain the misuse but not the fixed version of the misuse. And then we can notify the developers of those code repositories that they may have an API misuse. We did a preliminary evaluation of that approach on 43 API misuses and could generate 20 valid correction rules. And we also saw that we have an improvable misuse detection regarding to our very low precision and recall. Therefore, in the next steps, we want to revise our rule generation, in particular the type resolution, because that causes many invalid rules. And we also need other misuse criteria, for example, to cope alternative solutions like flush or close. And finally, we also want to have a bigger data set, for example, by generating misuses from the Android framework. All our dataset and scripts are available on Bitbucket. And now I want to finish my talk and I'm happy to take your questions.